Right, so these are the questions. Quite a lot to think about, and don't worry if you don't get all the stuff I talk about in the answer, but at least hopefully you'll get the basics. So we've got two conducting ping pong balls suspended from insulating thread, and they're going to be brought together. So this one here is going to be brought towards this one slowly. Come on. Brought towards this one slowly. Now the one on the left has a positive charge, the one on the right is neutral. What is going to happen? That's question one. Question two, same question, except instead of being suspended from insulated thread, this one's suspended from conducting metal wire, thin metal wire, which is then connected to earth. So again, the one on the left here gets brought towards it slowly. What's going to happen? Have a think about that. Try and write down what you think is going to happen, or draw some diagrams or something like that, and then watch the answers. So pause the video now. Okay, hopefully you've paused it and you've had a good think about what's going to happen. So we'll talk about the basics first, and then we'll talk about the more complicated answers second. So the basic answer is that, it keeps ungrouping. If I bring a positive sphere, conducting sphere, near to a neutral one, and they touch, then the charge that was on this sphere is going to spread out over the surface of both of them. Okay, so if we replace this one big plus sign with a load of individual little plus signs, however many we like, that charge is going to spread itself out over the surface of both of them because they are conducting spheres. Now they're both going to have a positive charge. If they both have a positive charge, what's going on here? There we go. If they both have a positive charge, they're then going to repel each other. So you're going to end up with something like this. So the spheres, you would bring them together, and then when they touched, they would then repel each other because the charge on one would have been transferred to the other. There's a little more to it than that. We'll come back to that in a second. What about this one here? Let's have a think with this one here. So we bring, and this one, by the way, is connected to earth, remember? Now, we bring the positively charged one nearer and nearer to this, and when they touch, the positive charge is going to spread itself over the entire combined surface of this sphere, and the earth. Now, because the earth is so absolutely massive, essentially it's just going to discharge, and all that charge is going to be transferred to the earth. So we're going to be left with two neutral ping pong balls, in which case I guess they'll just hang there and do nothing. Now there is one minor complication to this. There's a little bit more goes on than just these two basic things that I discussed. I'm not sure if this is on the syllabus or not, but it's worth talking about anyway, just because it's interesting. Now, before these two actually touch, if I just get rid of this, we rewind in time. Before these two ping pong balls actually touched, something interesting would happen. If the one on the left is charged and the one on the right is neutral, the positive charge on the one on the left would attract electrons over from the ping pong ball on the right, leaving behind a positive charge on the right hand side of the ball. So this ping pong ball on the right has become polarized. Now, the negative charges on the left are closer than the positive charges on the right. So the force of attraction between these charges and the sphere on the left is greater than the force of repulsion from the positive charges and the charged sphere on the left. So they would actually attract. So as you brought these two closer, before they repelled, they would actually attract together, touch, transfer the charge, share the charge equally between them, and then repel. So there'd be a slight attraction before contact and then repulsion. So that's just a slightly more complete picture of what would happen. Likewise with this one over here, this one here is charged again because we've gone back in time. Same thing's going to happen, okay, only slightly different. If you bring the positive sphere near to the neutral sphere, now you're going to attract electrons over here, but they can be attracted from the Earth. So these electrons have been nicked from the Earth, basically. They've been attracted up through this, all the way up through this Earth wire here, onto this sphere, which means that this sphere would now actually have a net negative charge. So this sphere would definitely be attracted to the positive sphere. So actually what would happen here is that as you brought them closer, again, the two spheres would attract, bash into each other, only this time when they bash into each other, the sphere on the left discharges totally, so then it would probably bounce off and then slowly just wobble and come to rest. So that's a slightly more accurate picture of what would happen. Hopefully with any luck we can actually try this next lesson with a couple of these ping pong balls and give it a go, and we'll see something like that. So I hope you had a good think about that and you at least maybe got the basic level of what was going on. The polarization thing is probably off the syllabus, but it's interesting to think about nonetheless.